Let's start with our situation here. The Finance Committee of a nonprofit summer camp for children is setting the cost for a 5-day camp. The fixed cost for the entire camp is $2,400 per day and includes such things as rent, salaries, insurance, and equipment. An outside food service company will provide meals at a cost of $3 per camper per meal. As a nonprofit camp, the camp must cover its costs but not make any profit. The committee must come up with a proposal for setting the fee for each camper, based on the number of campers who are expected to attend each week. Initially, the committee decides to calculate camper fees based on the fixed cost of the camp alone, without meals. So, what is the total fixed cost for the 5 days? Well, the fixed cost was that $2,400 per day, $2,400 for 5 days. So the total fixed cost for all 5 days is $12,000. Now let's think about how much that fee would be per camper. Guarantee we don't lose any money. So let's say we had 25 campers. How much would it be per camper? So take your $12,000 divided by 25, and it's going to cost $480 per camper. Ooh, that's a lot. So let's try doing, let's see about 50 campers. Will that help with the cost? Well, yeah, if I do 50 campers, that's going to be $240 per camper. What about if we have 75 campers for the week? Well, that would be $160. What if we have 100 campers? Well, that one's easier to calculate. That's $120. If we have 200 campers, well, that's going to be $60 each. It's getting a little bit better, isn't it? What if we have 500 campers? Well, that's a lot better. That's going to cost us $24 per camper. How much is it going to cost for 1,000 campers? Well, that ends up being $12 a piece. So whatever number of campers we have, what we were doing to find the fee per camper was taking 12,000 divided by the number of campers. Well, let's look at this in a graph. Notice that this is a little bit different than what we've done in the past, where we multiplied our input by a certain number. This time we're taking that certain number and dividing by our input, or the number of campers. So let's think how we would want to scale this. We went all the way to let's see, the fee was at 480. So what if we made this 500? 400, 300, 200. That works. 100, 200, 300, and 400. So really each of these would be 50. Okay? And then the number of campers, we got all the way to 1,000. So, let's see. What if we counted by 25? 25, 50, 75, this would be 100. 25, 150, this would be 200, 225, 250, 275, this would be 300, this would be 400, and we'll just go all the way up to 500 for this one. So let's think. Okay, we had, go back to my table here, 25 campers was at like 480. 50 campers was 240. 75 campers was at 160. 100 campers would be at 120. 200 campers we had at 60. and 500 campers was at 24, and then 1,000 campers is really far down. So we've got this. It almost looks like that decreasing growth, and it is decreasing. Our rule that we came up with was that we were going to take that total fee divided by the number of campers. X is that number of campers, and our f of x is that fee per camper. So we talked about that this graph is decreasing. Now, one thing also about it is it's discrete. It's singular points. You can't have half a camper. It's also all positives. As our x values get bigger, our y values approach 0. So it would get down to where if you had enough people, if you had 12,000 people, it'd be $1 a piece. That's really cheap. Now, is there going to be a minimum camper fee? Well, it depends on how many campers we can hold. I mean, if we could hold those 1,000 campers, that's really great. If it holds 500 campers, then our minimum fee would be $24. It really depends on the capacity of the camp for that one. Now, that rule did not account for meals. So let's think if the campers are eating 3 meals a day at a cost of $3 per camper per meal. Let's think how we can figure out how much this is going to cost. So what would be the total cost for meals per camper for each 5-day period? So they're doing 3 meals at $3 a camper each day for 5 days. So that would be $45 for that week. So now let's see how this is going to work. So our fixed cost plus the cost of meals. So I'll kind of write this one out. We had the $12,000 plus $45 for each camper for 25 campers. Our total fixed cost then would be $13,125. Per camper, that results in $525 because I took this total cost plus the meals and divided by the number of campers. See if, as I fill these in, you can come up with the other ones yourself. The next one, you would take 12,000 plus 45 times 50, and I hope you get 14,250. Per camper is $285. So if we need to pause the video for a moment so that you can fill in the rest of this table, please do so. So to find that cost, the total cost, it was that fixed cost of $12,000 plus 45 times the number of campers. Now to find that fee per camper, we're going to take that total cost and divide by the number of campers. Let's see if we can get all the way to 1,000 this time. Let's count by 50s maybe. So this would be 100, 200, 300, 400, 500, 6, 7, 8, 9. Let's make this one go all the way to 1,000. And the fee per camper, let's see, let's count by 50s. And let's plot our graph. This is fee per camper based on the number of campers. So if we have 25 campers, it was way over. 50 campers was at $285. 100 campers is at $165. 200 campers is at $105. 500 campers was at $69. And 1,000 campers was at $57. So notice we still have a decreasing graph. It's still discrete points. They're not connected because you can't have half a camper. So the rule here that we came up with, 12,000 plus 45 times the number of campers, divided by the number of campers. That gives us our fee per camper. Now let's think on this one. Is there going to be a minimum camper's fee? Well, if you really think about it, you got to pay for the meals. That's out of pocket. Everything else can be covered by how many campers we have, but that $45 per camper is really covered, is really that minimum camper fee. Now, think back on the other one. Was there a minimum when we didn't include the cost of meals? It does change it, doesn't it? Okay, let's take a deeper look at this situation on the next page. The summer camp is so rewarding that the Finance Committee decides to award 30 scholarships to students who wouldn't already be able to go. To help account for the scholarships, let's think back on what each of these would be. So we had our table over here, that fixed cost plus the cost of meals. For 50 campers, I'm looking back at my other table, we had $14,250. For 75, we had $15,375. 100 was $16,500. 200 was $21,000. And I'm getting these off of the table that was on 419 that we already filled in. Because think about what's going to change here. If I have 30 scholarships, then not all of these campers are paying. How many are actually paying? So let's think through it. If we had 50 campers, 30 get the scholarship, so only 20 are actually paying. That means that fixed cost of $14,250 is not being divided amongst 50 campers anymore. Only 20 of them are paying. So that leaves us with $712.50 per camper. I took this and divided by the number of paying campers. If we had 75 campers, 30 are getting the scholarship, that leaves us with 45 paying. What's going to be the fee per camper? $341.67. So if we have 100 campers, that gives us 70 paying. Each camper would be paying $235.71. 200 campers, that'd be 170. That's $123.53. 500 campers would be 470 paying for $73.40. 1,000 campers would be 970, and they'd be paying $58.76. So let's think how that would change our formula from the last time. Last time we were just dividing by the total number of campers. Well, this time if 30 are getting a scholarship, it's not the total paying, but it's 30 less because 30 are getting that scholarship. So that gives me 12,000 plus 45x actually being divided by x minus 30 this time. Let's see what happens to our graph. So I'm going to do the same scale we did on the last one. This would be 100, 200, 3, 4, 500, 6, 7, 8, 9, and then this was 1,000. Sorry if the video seems a little choppy. I kind of lost video recording in the middle, and so I'm having to finish it on another page. Now we just made a table of the fixed cost plus the cost of meals, the number of paying campers, and the fee per paying camper. And in I just started making the table, so I was going to count by 100. So 100, 200, 300, 400. This would be 500, 600, 700, 800, 900, and 1,000. And what if we go 50, 100, 200, 300, 400, 500, 600, up to 700 on our y-axis for the fee per paying camper. So if we plot those points, if we had 50 total campers, they were going to be paying $712 a piece. Now I have a question here. Why is this one starting off at 50 campers when our previous table started off at 25 campers? Well, if we're giving 30 scholarships away to students, we got to have more than 35, right? More than 30, so that we get a little bit of money out of them, right? Okay, so 50 students would be $725. 75 students is $341. 100 students was $235. Whoops, I was on the wrong line. X that out. 200 students is $123. Notice it's decreasing again. 500 students is at $73, which is a little bit over 50. And 1,000 is just a touch over 50 as well. It's at like 58.76. So we still have that nice decreasing graph. It's still all positives. It's still all discrete numbers. And if we look back at the rule we made, if you'll flip over, that algebraic rule was f of x equals, and then we had 12,000 plus 45x over x minus 30. And we're supposed to talk about the numerator and denominator, but I want to talk about everything. F of x is that fee per camper, right? The numerator up here, that is representing the cost plus food for that whole week of camping. The denominator, the bottom of our fraction, x minus 30, that represents the number of paying campers. Remember, even if we're going to have 50 campers, only 20 would be paying because we're going to subtract those 30 that had scholarships. So is there a minimum fee? Well, we still have to get that $45 for each meal, right? So there is a minimum of $45. Now, if we think logically, we're also going to have to pay for that set cost for running the camp for a minimum of 30 students, right? 30 campers, right? So you would also have that 12,000 divided by 30, huh? Because we have to at least pay for those 30. Now let's get into a little bit more detail. What if we knew, so if you flip over to page 423, what if we knew how much they paid last year? So let's say we knew that last year the camper fee was $80. They really don't want to change that same the camper fee. But they also want to grant those 30 scholarships. So how many people do we have to have attend? Changes it up a little bit. So, remember, this function was finding that rate per camper based on the number of campers. So we need to know how many people we need to invite to keep that cost down to $80 per camper. So remember, this is our cost per camper. We want that to be 80. So let's set it equal to 80. Now, we want to solve for x, and at first I know this looks scary. We've got a fraction equals another number. Well, what if I make this one into a fraction as well? Then all we have to do is cross multiply. So if I cross multiply, I'll have 80 times that denominator, so 80 times x minus 30 equals 1 times that numerator, so 1 times 12,000 plus 45x. I didn't really need to do that step, did I? Let's distribute. I get 80x minus 2,400 equals, distribute here, 12,000 plus 45x. Now, although they're big numbers, we're just solving equations just like normal. We're going to get our x's all on one side. So let's subtract 45x from both sides. That leaves me with 35x minus 2,400 equals 12,000. Get x by itself. Add 2,400 to each side. Now I have 35x equals, if I add 2,400, it's going to give me 14,400. Divide. X is 411.429. Now let's think about in the context of what that means. X was representing the number of campers. Can I have 0.4 campers? Oh, don't be silly. So I need to have 412 campers. But let's look at what the question says. It says the minimum number of paying campers. So while there's 412 campers, only 382 would be paying campers. Let's continue to look at this activity and see if we can find out a little bit more about this function. So let's graph it in our calculator. Now we're going to graph it over all numbers, and let's forget the situation for a minute. Let's pretend like we don't know that we're talking about campers and money, and that we can actually have decimals and all that good stuff. Now when we enter this in our calculator, there's two ways you can enter it. You can enter it with your numerator and denominator in parentheses like this, 12,000 plus 45x divided by x minus 30. That's one way we can enter it in. If you have one of the newer calculators, we have the fraction option as well. So if you get an alpha F1, we can enter it in as a fraction. So you can actually put the 12,000 plus 45x in the numerator and x minus 30 in the denominator. Now it says we're going to graph it on our graphing calculator using this set window. So that means these are our x values and those are our y values. So go to Window, and let's make our x values match that. So negative 450 to 450. and it didn't tell us what scale to use, so we'll leave that blank. And the y values, so y minimum is going to be negative 400, and the max is going to be positive 400. So let's look at our graph. Interesting. Kind of looks like some of the stuff up on the ceiling, doesn't it? The only part we saw before was this right branch. And that's because we were talking about a real-life situation where we only could deal with positive numbers. If we were not dealing with the situation, negative numbers could get plugged in for x. That's not a big deal. So we could use the calculator to approximate our x-intercepts and our y-intercepts. And I'm okay with us doing it that way, but let's also talk about, well, I like to be exact. I don't know about y'all, but I like to be exact. So let's think, how do I find, let's just say our y-intercept? Well, our y-intercept is when x is 0. So let's go ahead. I'm going to just do it exact. So the y-intercept is when x is 0. So set x equal to 0 to find the y-intercept. So when I go back to my function, that's going to be 12,000 plus 45 times 0 divided by 0 minus 30. Well, notice 45 times 0 is 0, and that's just 0 minus 30. So I end up with 12,000 divided by negative 30, which gives me a y-intercept of negative 400. Now, for the x-intercept, I have to set y equal to 0. And let me show you something kind of neat. When you have a fraction, the only way for a fraction to equal 0, remember the denominator can never be 0, so the only way for a fraction to equal 0 is if the numerator is 0. And even if you don't believe me on that one, if I cross-multiplied 0 times all of this, would just be 0. I'm left with 0 equals 12,000 plus 45x. So I'm going to subtract 12,000 and divide by 45. So I get negative 266.67, something like that. So finding x-intercepts and y-intercepts is the same. Y-intercept, you set x to be 0. X-intercept, you let y be 0. Now, I mentioned here that you can never divide by 0. It's totally undefined. It's illegal. It's bad. So, the function is not defined when x equals what? Well, it's a bad number if x is 30. So that tells us something about our domain. Our domain is that x cannot be 30. And I'm okay with us just doing it like this. Now let's think about the range. What's the range of this number? What am I getting out? Let's see what kind of y values we can get. So I'm going to look at my table for a second. Ooh, lots of negatives, huh? They're just getting worse. There's something keen about 30. Ooh, look what happens when x is 30. I get an error. Let's go back to our graph. if I hit trace and go along my graph, do you see that it's kind of leveling off, going this way or going to the left? Let's see where it levels off. What y value do you think it's going to level off at? And remember, our y value, let's think about the situation for a second. Our y value is fee per camper. Is there an exact minimum fee per camper? Well, remember, we had to have at least how much? 45. Now, we had to have more than that to actually run things. If we just charged 45, that wouldn't work. So we actually have a range where we cannot be just 45. It does level off at 45. This is also because we have a vertical asymptote. And if you look at the graph, you can kind of see it. At x equals 30, we can never reach 30. So we have what is called a vertical asymptote at 30. We also can't be just at 45. We have to be above it, or, well, in the real life, in the non-real life case, below it. But the horizontal asymptote is at y equals 45. Notice how the domain and range kind of match up with our vertical and horizontal asymptotes. We're going to be going into more detail on these next time.